Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Happy New Year and welcome to the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Each episode, we share the latest discoveries, observing techniques, and stories from the people who explore the moon, planets, comets, and beyond. Whether you're looking through the backyard telescope or a leading professional researcher, we're all united under one sky. I'm Tim Robertson, your host, and thanks for being here. Now, if you usually listen to the podcast in your car or on your phone, did you know you can now watch it as well? That's right. The Observer's Notebook is available as a video right here on the ALPO YouTube channel. And here's another interesting fact. Over 50% of the people that are watching or listening are not subscribed. So take a quick second, hit that subscribe button, ring that bell so you don't miss another episode. It's free and it really helps our channel grow. This show is made possible from support from you, our listeners and viewers. To help the Observer's Notebook going, you can check out our Patreon page at patreon.com/Observer's Notebook. For just $1 a month, you're supporting the show. For $5, you receive early access to the podcast. For $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you're listed as a producer on the podcast. And of course, you can learn more about the ALPO. Just go to www.alpo-astronomy.org, where you can join for as little as $22 a year. And now let's get started with episode 226. And it's our annual Comets of the New Year with Carl Hergenrother. Enjoy. All right, I'd like to welcome everybody back to this special edition of the Observer's Notebook podcast. It's our annual Comets podcast with Carl Hergenrother. Welcome back, Carl.
Thanks for having me yet again. How many years has it been now?
It's 7,
Yep.
maybe 8. I don't know. We're moving right along. Now, you've talked about your history in astronomy and the ALPO a little bit, but for our new viewers and listeners, can you just tell us a little bit about how you got into comet observing and your role as a comet section coordinator?
Sure. I'm not quite sure why I got interested in comets, other than I've always have been.
Hmm.
I had a dad who our basement was full of books on everything, planes, trains, automobiles, a lot of stuff about the space program, and a few astronomy books. And one book in general was National Geographic's Our Universe, which had
Okay.
separate chapters on each object in the solar system and then stuff further out. And for whatever reason, and I was kind of a little precocious kid. I was reading this stuff when I was 5, 6, 7. I would bring Aviation Week into my kindergarten show and tell and go, "This is what pioneers saw at Saturn," stuff like that. And for some reason, I was really drawn to comets long before I'd ever seen a comet, and
Ah,
years before I would ever see a comet. I was just interested in comets. And of course, we're talking 1979, 1980. And for those of us gray hairs may remember, that was not a great time for great comets. I was born too late to have seen, Bennett,
hmm.
Kohoutek, West, and then Halley wouldn't, show up until 85, 86,
Yeah.
which ended up being the first comet I ever saw
Oh, I didn't know
visually,
that.
was Halley.
Oh,
It
very
wasn't the
cool.
first comet I tried to see, but it was
Okay.
the first comet I successfully saw.
Okay.
Like I knew about Iras-Araki Alcock, it was in the newspaper. I didn't know where to look.
Hmm.
So who knows if I would have seen it or not.
Yeah.
So that just, I was always interested in astronomy and in particular observational astronomy, starting in my backyard. And comets was what I was drawn to.
Hmm.
And then, I started with my dad's old, I think circa 1959, 60 millimeter Sears refractor that I think a lot of us probably
Hmm.
started with
Yep.
or inherited. And then luckily, summer of '89, I upgraded to a 6-inch reflector, a Meade Schmidt Newtonian.
Oh,
Great little telescope. And once I did that, I was able to not only observe comets, but I learned about the ALPO and I joined. I learned about the International Comet Quarterly and
hmm.
joined and started making observations of comets, magnitude estimates starting there 1989-ish. And so,
Oh, wow.
and then I kind of had to make the hard decision. What was I going to study in college? And originally I was going to be an aerospace engineer, but I really loved astronomy. So like last week before I actually had to like pick which schools to go to. I'm like, I'm going to apply to astronomy school. So I applied to University of Arizona out here in Tucson, where I'm still at, and started in the astronomy program. Ended up getting my degree in atmospheric sciences.
Oh,
But it's funny because I've never used that degree at all professionally. And I, very quickly went to astronomy. But yeah, I was lucky in that there were people at the University of Arizona who studied comets. In fact, my first astronomy lab instructor was a senior undergrad. And he's like, oh, I use the 21-inch telescope on campus. I'm the lead telescope operator. Like, oh, I need to get access to this telescope. So I went up after class and I said, can I use this telescope? He's like, well, what do you observe? Probably deep space objects. I'm like, no, comets. And his face lit up. And he knocks on the door of his boss and is like, we got another comet guy here. And it turns out, he was a comet guy. He was working for Steve Larson, who was a comet guy. And that ended up, I started working for them. Me and that instructor, Tim Spar, would end up teaming up and did our own photographic survey
oh my.
with a Schmidt telescope that was underutilized here at the University of Arizona. Eventually did discover a comet in 1996, as
Hmm.
well as a few near-Earth asteroids. That project eventually morphed into the Catalina Sky Survey when we replaced the photographic capability with a CCD. And now, Catalina Sky Survey, every time you see a comet Catalina, comet Lemon, you're going to see a comet Christensen, as I'm talking about the comets of 2025 here,
Okay.
as well as a lot of other Kowalski, Foles, Spar, Hergenrother, a whole bunch of different names. All the McNaught comets in the 2000s, as well as the Siding Spring comets. Those are all done by the Catalina Sky Survey or offshoots of the
Wow.
Catalina Sky Survey. So yeah, that project, which started as just me and another undergrad wanting to discover a comet, turned into the probably most prolific, if not second most prolific, near-Earth asteroid discovery program, and
Yeah.
discovered a lot of other comets.
I did not know that. That's awesome.
But how did I end up here at the ALPO? Like I said, I joined around 1990-ish
Hmm.
and subscribed well into the 90s, and then I let my membership lapse because I was doing a lot of observing. And I would spend like 2 weeks a month at a professional telescope, which means I was not in the mood to do any observing in my backyard. That
Right.
was time for sleep. But then I became part of the OSIRIS-REx asteroid sample return mission, which was run here at the University of Arizona. And that kind of killed my professional observing career. I couldn't go observing and then be expected to be sitting in at meetings from 8 to 5 every day.
Mm.
And so, with no professional observing anymore, I started getting that itch I needed to scratch to go start observing again. And I started doing meteor stuff, some comet stuff, did a lot of stuff in my backyard. And this is about 2012 or so. And I joined the ALPO. And then when I was reading through the notes of one of the annual meetings that the Comets section could use some help, I
Hmm.
offered to be assistant coordinator. And then a year or two later, I became the lead coordinator and have been ever since.
Wow, that's a great story. I did not know any of that.
Yep.
Fantastic. So 2025 was an interesting year.
Oh yeah.
A year ago when we did this podcast, it didn't look like much.
I felt bad because after I did that podcast, I'm like, oh man, I came across so pessimistic because when you looked at it, it didn't look like there was going to be anything to see. I
Well,
mean, there'd
being
be
a
a few
being a comet
comets.
observer, you are naturally pessimistic.
Yes, yes, that's true. There's a bit of reality that kicks you
Yeah,
upside the head
yeah,
every couple months, it seems.
yeah, yeah. So
But
tell us about
yeah,
this.
so this year, which was supposed to be a slow year actually turned out, and it was slow for most of the year. And then, boy, September, things kicked into the high gear. And I'll have to admit, these last couple months has been the busiest period I've had as ALPO Comets Section coordinator
Oh, wow.
and the most observations coming in
Oh,
because there's just been so many comets out there.
that's great. So, do you have any highlights of this year you want to share?
So yeah, so what I'm going to talk about for this podcast, even though it's the comets of 2026, I'm going to start off just kind of recapping what we saw in 2025 with some of the brighter and more interesting comets that we observed. Then I'll talk about those comets that are expected to become at least brighter than magnitude 10 during
Okay,
2026. And there's a reason why I have an old woodcut picture here of the Great Comet of 1744. There was some interesting new news that came out about this comet in the last year, and I'll be talking about that at the very end.
great.
So in 2025, here at the ALPO Comets section, we received over 2,000 magnitude estimates
Wow.
of 135 different comets. So even though we're only going to talk about a handful of the bright comets, there are hundreds of fainter comets that are buzzing around. And these are comets that can be observed mostly, by, I want to just say, modest sized telescopes, so us amateurs have access to. If you were a professional telescope with a 4-meter telescope, you might be able to have tracked 400 comets if you
Hmm.
really, really tried hard. We also got nearly 900 images and sketches of 76 different comets. And for the brightest comets of the year, and these are just the magnitudes in some cases for comets, these are the magnitudes that we saw from Earth. Some of these comets actually got a little brighter. So the brightest comet was this 2024 G3 Atlas at negative 2.5 magnitude. Now, negative 2.5 magnitude is the brightness roughly of Jupiter. Now, you may be wondering, well, how did I miss a Jupiter brightness comet in the sky if you didn't see it? Well, it's because when this comet was actually at its brightest, this comet was more like negative 4. Now you're talking in almost Venus brightness. But when this comet was at its brightest, it was also a few degrees from the sun.
Right.
So it wasn't observable from the ground, or it wasn't easily observable from the ground. And then even when it was negative 2.5 here, it was observable in extremely bright twilight, and only for a day or two, because it rapidly faded as it moved away from the sun. So this was not a negative 2 magnitude comet in the dark sky overhead. It was a typical bright comet very close to the sun in bright twilight.
Okay.
We had another borderline naked eye comet in C 2025 A6 Lemon, which got up to around magnitude 4. And that was a pretty exciting comet because it
Hmm.
was discovered in January 2025. So it was discovered this year. So we didn't know about it last year. It wasn't very bright coming in, and then also surprised us by turning on, becoming much brighter. And during this fall, Northern Hemisphere fall, it was a nice fourth magnitude comet in the evening sky. We had two surprise Swan comets. Swan is an instrument on the SOHO spacecraft, looks at the sun, but it has an instrument that's actually looking at the entire solar system in Lyman Alpha. So it's looking at ionized hydrogen throughout the solar system. And it's doing that mostly because it's looking at the solar wind and the solar
Okay.
atmosphere. But because comets have a lot of water and water breaks up when you have the UV radiation hitting it, the comets have a huge hydrogen coma around them. So they turn out to be very obvious in these swan images if they're brighter than about 10th or 11th magnitude. So these were two comets that were discovered. R2 Swan got up to about fifth magnitude. Again, this was a September October object. F2 Swan only got up to about 7 or 8 because it fell apart. It was supposed to get brighter.
Hmm.
And then we've had a few Atlas comets, the most famous of which is 3I Atlas, which is the interstellar comet, which again was one that wasn't very bright at discovery and wasn't getting very bright and then really kicked into high gear and surprisingly was observable visually in pretty small aperture telescopes. And then 2025 K1 Atlas may actually be my favorite comet of the year
Oh.
because that one, unlike F2, which completely disintegrated and fell apart pretty rapidly, K1 is breaking into pieces, but it's still holding together enough that we've been able to track it for the last few weeks and months as it falls apart.
Yeah, that's been pretty interesting to watch online. You guys see the the pieces of they're still tightly clumped together in the head of the comet.
They are, and actually, spoiler alert, I have a movie over the last month or so showing these pieces breaking apart and spreading
Oh,
apart.
okay.
So let's go into a little deeper dive in some of these 2025 comets. So the one I talked about initially, the really bright one, was C 2024 G3 Atlas.
Hmm.
Came to perihelion in the middle of January, pretty close to the sun. 0.093 AU means that's 9.3% of the distance between the Earth to the sun. So it was extremely close, got extremely hot. It was a dynamically old comet, we think. What that means is we think it's been had a previous close approach to the sun in the past.
Okay.
And now usually dynamically old means they're more likely to survive passing close to the sun. Dynamically new comets, which are making their first trip through the solar system, their first close pass, have a higher likelihood of falling apart.
Okay.
So we were kind of surprised when this one, got through, made it through perihelion, but then a week later fell apart.
Hmm.
Nucleus completely disintegrated. And so here you can see the light curve from ALPO data, as well as some SOHO photometry. That's that same spacecraft I was talking before. That was reduced and submitted to the Cobb's website. So it's not ALPO data, but it's stuff I grabbed because it nicely filled in a part of the light curve that we
Okay.
didn't have. And as a Mieczyslaw Paradowski was the one who did that, and that's mostly the data that you see right here. And it showed that the comet did get up to about negative fourth magnitude when it was close to the sun.
Hmm.
And Chris Scher, who's up here, northern part of Arizona,
Hmm.
was able to observe the comet. This is all these images you see at the top were taken at noon, middle of the day at noon,
Really?
with his, I think it was his 10-inch telescope, though he did modify it to cut down on scattered light from the sun. And so these are all daytime observations. If you
Interesting.
look in the lower left, there's a picture January 16th. Mike Olison, also here in Arizona, closer to me here in Tucson. And this picture was taken in the evening, twilight. Sky was still bright. And I like this picture because that's kind of what the comet looked like to me when I was looking in just 10 by 50 binoculars.
Hmm.
And this was a comet where I'll have to admit, it came up from south of the sun. So it was really a southern hemisphere only comet. And it was only observable from the northern hemisphere right as it was kind of going closest to the sun over the top. So I wasn't sure if anyone in the northern hemisphere would see it. And so I remember going out one evening, I think it was a few days before the 16th, it might have been the 14th, with looking with my binoculars, didn't see it. Okay, I spent like half hour, couldn't see it. Next night, January 15th, I'm like, you know what? I'll go out there for, I don't know, 30 seconds just to see it or not. Went out there, 5 seconds later, I saw that. I'm like, whoa,
Oh my.
negative 2.5 magnitude. I'm like, that's pretty cool. That I just saw another negative magnitude comet only a few months after Comet 2023A,
That's
which would be
crazy.
Shushan Atlas. Though again, observing under those same conditions where you're looking at really bright twilight,
Hmm.
so it wasn't visually obvious. Though I could see this one slightly naked eye eventually. And then it rapidly faded. Here's the next night after I first saw it on the 16th. And that night was interesting because I couldn't find it again.
Hmm.
Because it had faded from negative 2.5 to about negative 1.3, and I couldn't find it. It wasn't against a bright
Okay.
background. I couldn't get my eyes focused. Lucky for me, there was a Black Hawk helicopter flying over the house. So I trained my binoculars just to watch the Black Hawk as it was going by, give me something else to look at. And it happened to go right through the field of view with the comet. And
Oh,
because I was focused on infinity or close to infinity on the helicopter, all of a sudden I see the comet snap into view. I'm like, oh,
oh
thank
my
you.
goodness.
Thank
That's
you, U.S. Army. So yeah,
that's a crazy technique.
yes, very fortuitous.
Uh-huh. Wow.
And only 2 days, 3 days after this picture by Mike Olson there, the comet nucleus fell apart.
Hmm.
So the picture on the lower left is what we saw at our best from the northern hemisphere. The picture on the lower right is what they saw in the southern hemisphere.
That's crazy. That kind of resembles Comet West a little bit. This the way the
Yeah,
tails
you
spread
can
out.
see the striations,
Yeah, yeah.
the striae. in the tail. You also get these little
Yep.
faint gossamer ghostly streamers, which is dust that was released, weeks before the comet actually,
Hmm.
weeks before this picture was taken. And there are people, and I mean, at least based on the images I've seen, who legitimately claim this should be considered a great comet. So this really should be the great comet of 2025.
That's a pretty impressive photo.
Yeah, and then as I mentioned, that week after perihelion, around January 18th, 19th, the nucleus disintegrated.
Hmm.
And here, like at the upper image by Michael Yeager, which was taken maybe about 6 days after the nucleus disintegrated, you can see there's no real condensation to the coma anymore
Mm-mm.
here in the front. But you have this bright streamer, and that's probably the remaining dust when the nucleus completely disintegrated and blew back. And the amazing thing about this is that this remnant dust cloud was followed for months afterwards. I mean, we got a picture here from, 2 weeks after the picture up top, and then there's a picture here end of April. There was an observer who's been posting on the Cloudy Nights forum, Robert Kaufman, who was able to follow this ghost tail into late June. We're
I,
talking 6 months after the nucleus
I
disintegrated.
don't remember ever seeing anything similar to this. I mean,
Right.
just
So kind of what happens here is that usually when comets break up, and we're going to see an example of one of
uh-huh.
those coming up soon here, they break up before perihelion, before they get super close to the sun. If you can survive perihelion, even for a few hours, let alone a few days, that's when most, especially when you're getting really close to the sun, that's when most of the dust is released. Like when these sun grazing comets come in, like,
Hmm.
Ikeya Seiki in 65, and of course we had the Lovejoy comet, which was a great example back in
Right.
2011. All the dust that it releases before perihelion is blown away or destroyed by coming really close to the sun.
Okay.
And then the new tails formed in the hours, the days after perihelion. So as
Okay.
long as you can survive perihelion for these very low perihelion distance comets, the tail will just be created and exist and slowly blow away in the solar wind as the orbit motion in the solar wind pushes the stuff away.
That's crazy because I'm used to seeing a central condensation in the core, and there's
Yeah.
nothing there.
So now it's all in the tail. All that stuff is in the tail now. So they call these headless wonders.
Huh.
Because
Okay.
1887, there was a sun-grazing comet that was, discovered as just a tail popping out, and then all of a sudden they're like, it's only tail. There was no coma because the nucleus had disintegrated beforehand.
That's
So it
wild.
makes you wonder how many of these great comets in the past were doing this.
Hmm.
How many of these great comets in the past were doing this, where, and we do have records of comets that are really bright and then they rapidly faded out. And so you wonder the reason why they rapidly faded out was because the nucleus actually disintegrated.
Wow.
And all you had was this kind of ghost tail remnant.
That's pretty wild.
So that's how 2025 started off. And then we weren't expecting to have much, at least until later on in the year.
Hmm.
Luckily, we had a comet discovered. This was about Aprilish time frame, March, April, 2024 F2 Swan. This was expected to become a reasonably bright comet, but unfortunately, about 2, 3 weeks before it could get to perihelion, it disintegrated. Its nucleus fell apart. And there's different ways you can tell whether or not a comet has fallen apart. The most obvious is that, rather than comet having a nice condensed coma, the coma becomes diffuse and spreads out. It starts looking more like this, like the other comet and this comet. It's kind of a ghost tail. Another thing is to look at the orbit. And what I have plotted up here is, these are observations, astrometric observations taken from the Minor Planet Center. And I'm plotting the orbit, and these are the residuals, and they're all pretty low, within roughly an arc second, which is what you expect. The different colors are just residuals in RA and DEC. And residual is the offset from the expected position based on
Okay.
the orbit for that time. And yeah, there's some noisy ones, but that happens with comets because they're hard to measure. And then all of a sudden, around April 16th, it diverges.
Huh.
And so what you're seeing is the nucleus is completely fallen apart. And what we usually measure is the brightest part of the coma, and that's usually where the nucleus is, usually. Sometimes it can be offset by jets and stuff like that. But if the comet completely disintegrates, it just becomes a dust cloud, and the solar wind is like a wind. It starts blowing it back from its predicted position. So, like in this picture here, you can just barely see the dust cloud.
Hmm.
And I don't know exactly where the predicted position of the comet should be based on this. It's something maybe I should look into. But it's probably out here in front. So it's probably just getting blown back.
Okay.
So looking at the orbit does give you an idea of when things have fallen apart.
Hmm.
Sometimes you notice that before you notice it over here in the images here.
Okay. Wow.
We had another Swan comet
Mhm.
discovered in late August, early September, um, 2025 R2 Swan. And this was cool because this was a time where, again, there'd been a few months where nothing was going on. There weren't any real bright comets. And we really weren't expecting any real bright comets either, for the most part. And then the Swan comet was discovered. And at first, it was only observable from the southern hemisphere. This picture here by Michael Yeager and Gerald Riemann. That's Spica, the brightest star in Virgo.
Okay.
This is 2, 3 degrees of tail. So, boom. And this was a comet that snuck up on us because it was kind of coming from behind the sun. It wasn't easily observable from Earth. And there's some evidence here. This light curve is just extrapolating this part here, but it may
Okay.
actually have dipped down. So it may have brightened very rapidly as it came in August. So it might have been too faint to have been seen from the ground when it was further out. And then this comet, as you can see here, late September, all of a sudden, boom, has a little half magnitude, 1 magnitude outburst. And now it's 6 magnitude. And now it's getting to be observable from the northern hemisphere. And then it has another outburst, another little outburst. And it actually had a splitting event. There were a few images that showed evidence of a secondary nucleus there.
Hmm.
And it stayed reasonably bright. I mean, this is almost about a month and a half where you had a comet that was about fifth, 6 magnitude. And it also got pretty close to the Earth. That's about 0.26 AU here, late October. And now that it's past perihelion, it's past closest approach, it started fading after that. And this is a comet that comes around every 800 years. So this actually is a reasonably old comet.
Okay.
And the picture now, even though it's from about a month ago, here in the upper right, shows two tails.
Hmm.
So you've got the sun is off to the lower right. So the main dust tail is blowing off to the upper left here.
Okay.
And then you've got an anti-tail here. And it's hard to tell, but there's actually dust kind of all the way around here as we're looking at the plane of the comet's orbit. And if you look at this edge of this anti-tail, it does suggest that this is dust that was released back in mid-August, which would kind of verify what people have been presuming and even have
Okay.
seen with some of the space-based stuff that it really didn't turn on until August, which is why we didn't see this comet months in advance coming in. So that was a nice surprise comet.
Hmm.
And then the brightest comet of the late 2025 was C 2025 A6 Lemon, which was discovered back in January. Not very bright and wasn't getting very bright. In fact, it was brightening at the same rate you would expect an asteroid to brighten. So it was suggesting that if it was active, it was not very active at that time. And then it went behind the sun, solar conjunction. And then when it popped back out, we were only expecting it to be about 18th magnitude. And instead, it pops out and it's 14th magnitude. And then over the course of a week or so, now it's 10th magnitude. So it turned on as it was coming in. And this is another relatively old comet. I mean, old in that it's been around a few times because it's got a 1400-year period.
Oh, wow.
So it's made a few passes around before. And then eventually, this is late October. This is around its time of its closest approach to Earth, which was at zero point 0.6 AU. It reached its brightness about fourth magnitude. It was a nice comet there in the evening sky. And again, you can look at it with binoculars, even in some of the cruddy skies I was observing with, and
Hmm.
always see half degree of tail. Some of the imagers saw dust jets, and this picture here, actually not a picture, it's a sketch by Paul Abel from the UK, Also shows evidence of maybe some dust jets or shells near the nucleus there.
Hmm.
So in a way, Lemon was also surprised because it wasn't expected to be bright, and it became extremely bright. And then the most recent comet, at least for the long period comets, and probably the brightest comet in the sky right now as we're recording this on December 12th, is C 2025 T1 Atlas. And this is a comet that's right now in the evening sky. It's a fuzzball comet, doesn't have much of a tail. It kind of looks like a cotton ball for the
Hmm.
most part. You'll see a lot of those comets here. It's about around magnitude 8.5. If you're watching this, say January 1st, 2026, by that point, the comet will have already faded below about 10th magnitude, 11th magnitude, and also getting pretty close to the horizon. So this really isn't going to be a comet of 2026. So this will
Okay.
be like, it all done its thing here all in 2025.
Okay.
And then this one didn't get quite as bright, only about magnitude 10 or 11, but it's kind of interesting. And if you remember that previous chart, it's one of our best observed comets. And the reason for that, this is Comet 2240P NEAT. NEAT stands for Near Earth Tracking, which was a JPL-based asteroid comet survey that used telescopes first on the island of Maui in Hawaii,
Okay.
and then eventually the 1.2 meter Schmidt telescope on Mount Palomar. And this comet was discovered early part of this century, early 2000s. I think this is its fourth observed return, but the last two returns have seen this comet experience major outbursts, like multiple 3 magnitude outbursts. And it's very possible that one of these probably the last time around, during one of those major outbursts, it shed a piece. And so we've got, the main nucleus, the main nucleus, so the main comet, which is around magnitude 10 or 11, maybe 12 now because it's starting to fade. And then this secondary, which got up to magnitude 14. There is some evidence. You don't really notice it on this light curve plot because this is only ALPO data. But when you look at the Minor Planet Center data, the comet did brighten from around 18 to 14 or so in June. So it may have had an outburst in June. And what we're seeing here is the comet kind of settling back down. And then we've also got this bump here, which was in November. And the question is that an outburst, or because the comet was going through opposition, very low phase angle, was that due to like an extreme opposition effect?
Okay.
Backscattering from dust will make the comet look brighter. So it's possible that's what's going on. But this is a comet, yeah, the last few times around, it's been full of surprises, either outbursts or now a secondary component, and a fairly long-lived one at that. So we'll see if this survives and comes around the next time.
Hmm.
And it's 7.6 year period there.
Now the data for this light curve, is this photometric data or is it visual data?
It's a mix of both.
Okay.
So
Because
right
I'm looking
now,
at the distribution. It's all over. It's really there's like a
this
magnitude and a
is,
half.
yeah, this is kind of an extreme one. Usually what I do is, I do mix and match visual
Hmm.
data and, digital data. And sometime I will kind of put in an offset bias to
Okay.
make things line up with each other. In general, the digital data is almost always, not always, but almost always like zero point 0.7 to 1 magnitude fainter than what's going on visually.
Oh,
And a
really?
lot of that, I think, is what we see. The V band, which is supposed to be what your eye sees, isn't what your eye sees at night. Your eye
Okay.
shifts more into the blue. And that's where all of the, when you go into the blue is where you get a lot of the gaseous emission. The
Okay.
reason why there's all these pictures of comets and they're blue-green, because
Hmm.
that's where the stuff is. Well, the V band is a little redder than that.
Okay.
So it's very possible that, visual versus most of the V band data or green filter data, which a lot of people use in lieu of V band, are just sampling different parts of the comet spectrum. And so that might be why the visual stuff is a little brighter because it's looking more into the blue. So that gets rid of the less interesting comets of 2025. Now we get into the truly interesting ones. So, of course, we have three Eye Atlas. This is the third known interstellar object,
Hmm.
there's a caveat there, in that we have observed many interstellar meteoroids, going back decades. But when you talk about a large object that you can actually detect out in space and track its orbit and blah, 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 this is the third of the large objects, not counting stuff we've seen, burning up in the Earth's atmosphere.
Okay.
And the comet was discovered around early July. It brightened at a, fairly good rate for a comet. Nothing too special, typical rate. And then all of a sudden around September 1st, it like kicked into gear and really brightened. And part of this reason could just be because, well, here's a comet that is screaming through the solar system faster than anything else that we've seen. And you're like your typical short period comet to go from the distance that 3I was at in early July, which is like 4.5 AU, down to a perihelion of 1.35 AU.
Hmm.
That takes over a year for a short period comet to do it. For a long period comet, a very typical parabolic E of 1 object, that still takes about 8, 9 months. For Atlas, it was able to do that in under 6 months.
Hmm.
So it really sped up and came up on the sun quickly. So maybe it just took time for the heat of the sun to really penetrate deep into the comet. So it turned on. Unfortunately, when it was at perihelion, as you can see here, it was behind the sun.
Right.
So it wasn't observable from the Earth. Luckily, we've got a whole flotilla of spacecraft looking at the sun and looking behind the sun. And of course, Mars was pretty close to where it went by. So some of the Mars missions were able to look at it. Some of the missions going to Jupiter were able to look at it. So actually, there was professional spacecraft data that filled in here. But it does look like the comet peaked around magnitude 9. And then when it popped out again in the morning sky, surprised everyone, it was still around magnitude 9-ish. And right now it's still probably around magnitude 9.5 or 10. Though by the time you're watching this, close to the end of December, maybe early January, it will have faded to 11th or 12th magnitude.
Okay.
But yeah, and the picture here is kind of interesting because you've got an anti-tail,
Hmm.
which could just be because the comet's racing faster than the dust it's releasing in a way, because it's moving through the solar system so fast. And then it's got this really kind of convoluted dynamic, almost like a fork-like gas tail, which is also pretty interesting. It's something we've seen with other comets, especially carbon-depleted comets. And I'll talk a little more about carbon-depleted comets with the next comet,
Okay.
which is C 2025 K1 Atlas.
Hmm.
Not an interstellar comet, bound to the sun, dynamically new, which means it's making its first approach. But if you look at this comet, and actually, we'll go back. Look at the difference between the coma and tail of 3I. It's got that typical blue-green coma, and the tail is very blue. And then you look at this one,
Yep.
and it's shades of yellow and red. There's a
Hmm.
little hint of green in the
Right.
coma. So what's going on here? Well, in general, comet tails and even cometary coma are not all blue-green. There's a little bit of red in there. It's just the red is usually kind of swamped by the you know the carbon species that produce the blue-green coma. But there's a lot of nitrogen NH3 out there that glows red. This comet is extremely carbon depleted or carbon poor. It doesn't have much carbon at all. So the blue that you would usually see in the tail just isn't there. And you're only seeing kind of the red tail that's showing.
Hmm.
So it's just got a very interesting composition. So this was a comet that, to be honest, it intrinsically faint, dynamically new, first passed through, and a lot of us were sitting there going, this one's probably going to disintegrate, maybe even before it gets to perihelion.
Hmm.
It came in, it was brightening pretty rapidly, and then it stopped brightening for a little bit, and even during this little stretch here between about August 1st and maybe August 10th, it even seemed to be fading. Then it started brightening again, but at a slower rate. And then we lost it as it got close to the sun. And so when it came back out in the morning sky, we were kind of surprised to see that the comet was still around ninth magnitude. Some of the images that were taken at that time when it was first reappearing in the morning did suggest that the comet maybe had experienced an outburst only in the day or two before that. And as you can see here, there was another outburst, another about one magnitude outburst that occurred in mid-November. But for a comet that we were expecting not to survive perihelion, it actually turns out the comet is breaking up. So here we've got images that were taken by the British Astronomical Association, the BAA, as well as a group called the Comet Chasers. And they're using a bunch of telescopes that are located at observatories that are owned and operated by the Las Cumbres Observatory. In particular, these are all images taken with a zero point 0.4 meter, different 0.4 meters, but they're all 0.4 meter telescopes. And the reason why the comet's kind of corkscrewing and spinning around is just because of the geometry, observing geometry is changing, and the
Hmm.
comet's going through opposition there. But as you can see, the comet, we'll wait till it begins here, starts off in one piece, and there is some evidence of kind of dust going out,
Right.
and then it starts breaking up into a bunch of multiple components. And as each of these components kind of drift back, they start falling apart and disintegrating. What's interesting now is that it's hard to tell which component is the primary
Ah,
because the one thought was the primary all along isn't there anymore.
oh
And the
my.
brightest component is one that's fallen behind. So most likely what's going on, and this is why we think most comets disintegrate. In some cases, it might be a nucleus that's really small. And when you go around the sun, you're going to, you vaporize, sublimate some amount of the ice where the comet shrinks. And maybe if it's really small, it shrinks away to nothing. But more likely, what's going on is this was a small nucleus to begin with. And when I mean small, I'm talking hundreds of meters, maybe half kilometer. And it's got jets as it's active. And those jets spin it up, and eventually it spins it up to the point where it just falls apart. We see this with asteroids. There's a reason why there are very, very, very few asteroids that are larger than about 200 meters in diameter that spin quicker than once every 2 hours. It's because they fall apart. And so with comets, which are even less dense than asteroids are, you probably, once you spin up to about a rotation rate of 3, 4, or 5 hours, it just falls apart into a bunch of different pieces. And that's probably what we're seeing here.
Okay.
So my guess is this comet is, and what remains of it is not long for, well, it's not really proper to say for this world, but for this solar system.
Okay.
So now let's start talking about the comets that are coming up,
Okay.
the comets of 2026. So the first comet is Comet 24P Shomas, which was discovered in 1911. It was a photographic discovery by Alexandre Shomas from Nice Observatory down in southern France. This is a comet that is having one of its better returns this year. The graph down here, what I have here plotted, is going back in time to just a little bit before that discovery in 1911. The triangles are the perihelion distance, and you can see for the most part, I mean, yeah, there's some close approaches to Jupiter every now and then, but for the most part, the perihelion distance has been pretty stable. And then the blue circles are the closest it comes to the Earth at each of these returns. Its best return was back in 1952 when it got even closer than it will be coming in 2026 and got up to about 6 magnitude. It had a nice return in 1993. I remember observing it during that return when it got up to around magnitude 8. And this return now will be similar to that 1993 return. And there'll be another really good return in like 2058, 2059 as well. So SHOMAS is going to be a morning object for this in pretty much the entirety of when it's bright. By the time the year starts, it should already be as bright as around magnitude 8.5. It'll peak at perihelion January 8th, and that's also around the same time when it comes closest to the Earth at about 0.59 AU. So as that first week or so of 2026 will be when this comet is at its best at around magnitude 8.4, 8.5. Be good all through January, and by about mid-February, it starts fading, and it drops below magnitude 10 or so. And you can see the path here. This is from a bunch of, if you really want good, it's probably the best comet star charts I can find online. So the Dominic Ford's inthesky.org website
Hmm.
is really good, especially if you want to know like where that and Stellarium are what I use for figuring out when comets are going to pass in front of different deep sky, space objects for good photo opportunities and stuff like that.
It has the comets already in it, and
It's
it'll
got
just
all the
pop up.
comets already in it. Yep.
Great.
Yep. It's really good. So yeah, that's 24P Shomas, which
Okay.
will be the brightest of at least the short period comets, or close to the brightest. There'll be one that will rival it. And just to kind of show a recent sketch of it, Shomas is kind of your typical short period comet. It's going to look like a fuzzball.
Okay.
Be surprised if we see much of a tail with this one, at least not visually. The next comet is C 2024 E1 Veritas. And this was a comet that was discovered, oh geez, we're talking almost a year and a half ago,
Hmm.
early 2024. And this comet, for the most part, brightened at a very, very steady rate from around discovery all the way until just recently, in the last like month or so, it's kind of started brightening even faster. And this is a comet that right now, as of the time we're recording this, is now dropping out of sight in the evening sky. And it's getting close to 10th or 11th magnitude. But as you can see, it'll start the year extremely close to the sun, to the point where it won't be observable from the Earth. But then it will pop out first in the southern sky, for southern hemisphere observers, around magnitude 7, and that'll be late January. Here in the northern hemisphere, we're really going to have to wait till mid-late February to get our good glimpses of this comet, and by then it'll have faded to about 8th magnitude. That's assuming that I make the assumption that this most recent brightening enhancement that it's been going through, this increase in brightening rate, won't continue. If it does continue, it actually could be a little bit brighter than this. And just to kind of show, here we are, its
Hmm.
path on the sky. You can see why it's such a good southern hemisphere
Yeah.
object, because it shoots down south of the sun, and I've got the sun linked on here, shown here. And then eventually it does work its way back north, and that's why we start picking it up again, kind of in that mid-February, late February timeframe. So unfortunately, this comet it will be located on the far side of the sun when it's at its best. So unlike, say, A6 Lemon, which was located on our side close to us, this one will be on the far side. So
Okay.
observing geometry won't be great for it. But there is a good possibility of a nice 7th magnitude comet for the southern hemisphere and 8th magnitude for the northern hemisphere, again, January, February timeframe.
Okay.
And this is just a recent picture of it showing a nice gas coma
Hmm.
and the formation there of a dust tail. So it does have some dust production, which bodes well.
Okay.
Going back to short period comets, we have Comet 88P Howell. This is a comet that really has turned into one of the better comets of the past few decades. It was discovered in 1981 by Ellen Howell, who I believe was an undergraduate at Caltech at the time.
Hmm.
Uh, I worked with her on OSIRIS-REx, and it was a photographic discovery. And as you can see, its perihelion distance actually was pretty far out, and then it dropped down when it was first discovered, and then dropped down again. And now it actually gets fairly close to the sun at 1.35 AU. Unfortunately, it never has a really, really super good approach to the Earth, just the way the geometries line up. But it's quite often been observed as bright as 8th magnitude. This return, unfortunately, is not a great one, as you can see.
Hmm.
It gets really no closer than about 1.5. Eventually, you'll get to 1.5 AU from the sun, but when it's at its brightest, it's still almost 2 AU from the sun out. Sorry, 2 AU from the Earth out. And it'll peak at around magnitude 10.0, maybe a little brighter. Unfortunately, as you can see by this 40N and 40S is the maximum height of the comet when the sky is dark. So basically outside of twilight.
Oh, okay.
So you see not good at all for Northern Hemisphere, but it will be predominantly a Southern Hemisphere object. And again, this one has a little bit of a tail there, but again, it's a nice fuzzball
Oh, that's a pretty
comet.
shot.
Yeah, that was from the last apparition.
Okay.
And then C 2025 R3 Pan-STARRS. This comet, not sure about. As you can see, I've only got one. There's actually a second data point. I just haven't plotted it on here, but there's not a lot of observations of this comet yet. Still pretty far out. Gets down to about zero point 0.5 AU from the sun with a perihelion on mid late April 2026. The reason why it shows its brightness is because it's going to be at high phase angle. So this has a lot of dust forward scattering enhancement there, which may or may not happen. So maybe this comet won't get this bright. But even when it's at this bright, as you can see by all these zeros here,
Yep.
it's not observable from the ground, at least not against the dark sky.
Okay.
So if this light curve holds, and if this comet actually survives perihelion, or as it gets close to perihelion, maybe in the northern hemisphere we'll catch it around magnitude 9, 8, maybe as bright as 7 before it gets too close to the sun. That's middle of April. And then the southern hemisphere will pick it up at the very end of April if it survives in May. But by then it will already be fading 7th, 8th, 9th magnitude. So this one's I got a huge question mark on.
Okay.
We'll see. But then again, I had a huge question mark on A6 and G3, and they turned out to be nice. So you never, never know.
That's true.
And just again showing the path
Yeah.
north of the sun. That's why we can see it from northern hemisphere, and then it shoots south of the sun, which is why you can only see it from the southern hemisphere post perihelion. Going again back to short period comets, 10P Temple. And
Hmm.
when you get down to the low numbers like 10P, you know this comet's been around a bit.
Right.
That means it's the 10th known comet to have been seen at more than one return. 1P Halley being, of course, the first, and then 2 Encke. So 10P is up there. It was discovered in 1873 by Wilhelm Temple, who discovered a lot of comets. Extremely large nucleus, like a 12 kilometer or 7 mile in diameter nucleus.
Hmm.
It's a comet that even, with pretty modest size backyard telescopes and a CCD, you could probably follow this thing all the way around its orbit because it's got such a large nucleus. Also pretty stable orbit all the way through, though it does look like it's slowly moving back out, at least from, the early 1900s till now. This is actually going to be a very good return for this comet. Probably the best return we've seen since about 1967,
Hmm.
when it did get up to around 8th magnitude. It's going to be the best return any of us will have ever seen because through the remainder of this century, it never comes closer to the
Okay.
Earth. And it should reach about magnitude 8.0, maybe 7.9. It'll be a summer object, at least here in the Northern Hemisphere,
Okay.
winter in the Southern Hemisphere. Again, as you can see, it's got a little bit of inclination. It starts in the Northern Hemisphere, Aquila, Capricornus, Aquarius, and then rapidly drops south. So if you're at a high northern latitude, you're going to run into trouble observing this comet by September, though by then it will be actually fading.
Hmm.
But this is, it's a kind of a neat comet because, like I said, it's got this large nucleus, and it doesn't turn on until a few months before perihelion. So if you ever want to at least image a, comet nucleus directly without any coma, this is one of the best opportunities to do so is with a comet like Temple.
Oh, okay.
I'm about to say Temple 2 because for a long time it
Right.
was Comet Temple 2, and then we removed the 2 and replaced it with 10P. And sometimes this comet does show nice coma features, coma morphology. You can see a dust jet and maybe even some spirals in there. So this could be a neat one to watch as it develops. And speaking of neat comets to watch, there's 169P neat, and I did not do that on purpose. This comet is a little bit of an oddball. It's not the only one like this, but as you look at that orbit, one thing you'll notice, and let's actually go through some of the other short period comets. One thing you notice, orbit gets fairly close to Jupiter, even closer to Jupiter,
Mm-hmm.
even past Jupiter.
Mm-hmm.
And of course, if you get close to Jupiter, and Jupiter can have a major effect on your orbital evolution and move your orbit
Right.
around its
Right.
gravity. But one thing that's interesting, and we'll pause here on Temple 2, is that it's doesn't quite get all that way out to Jupiter. So here's an example of a comet where one reason why its orbit is so stable and may have been stable for so long, and maybe one reason why it doesn't turn on until it gets close to the sun, because it's a very evolved, baked nucleus that maybe has lost a lot of the ices and such in the upper layers, is that you could be Temple 2. It's funny, they call it Temple 2 there.
Mm-hmm.
10P Temple could be an example of a comet that is slowly dying. When I mean dying, I mean it's running out of the ices that
Mm-hmm.
sublimate and turn into a coma and tail. And the reason why it might be doing that is because it's starting to what we call become decoupled from Jupiter. Can't get close to Jupiter, so Jupiter no longer has a major effect on it. And the reason for that could just be because as it goes around the sun, it's got, dust jets and they're pushing the comet here and there. And eventually maybe they just kind of shorten the orbit so it doesn't get that far out.
Yeah, and it's really not perturbed much from the sun either because it's what, 1.5 AU per billion?
Right.
Yeah. Okay.
Yeah. And the inner planets don't do much.
Yeah.
It's really the
Yeah.
outer
Yeah.
planets that do it. So here at 169P neat, we have a comet that is very decoupled from Jupiter.
Mm-hmm.
And so much so that there's actually been a few published papers that suggest that this isn't a comet at all, at least not in a traditional sense as an object that came from the Kuiper Belt, the Trans-Neptunian region, that this might be a main belt object.
Hmm.
Still very volatile rich, lots of ices, but was kicked in. So really you can think of this as a very icy near-Earth asteroid. And this is an object that only turns on when it gets within about 1 AU of the sun. So it has to get extremely close in order to become active. And this object was discovered in 2002.
Okay.
And so NEAT could get as bright as 6 magnitude, but again, we're talking about an object that's really close to the sun, and you're not going to be
Right.
able to see it from the ground. So maybe, and this also has more dust forward scattering, which maybe this object won't show that.
Okay.
210P Christensen was a comet that was observed in 2025. It got up to ninth magnitude, which was supposed to maybe get as bright as fourth or fifth magnitude when it was really close to the sun. And you'd only be able to see that with spacecraft data, but didn't quite get that bright. So maybe the forward scattering from the dust models here isn't going to work for these comets quite as much. But this is an example of a comet that start off in the northern hemisphere. Maybe it'll get as bright as 9th, 10th magnitude before we lose it, and then pop up again in the morning sky, again, mostly from the northern hemisphere, eventually in the southern hemisphere at maybe, 8th, 9th, 10th magnitude as well. And this is, we're talking the August, September timeframe.
Now I'm looking at the light curve and it looks like you have a bump right around that time. What would cause that?
So, you mean which
That right
one?
there. That right
Right,
there.
right there. The difference right there, and you'll see there's another bump over
Mm-hmm.
here in late November. So this original coming in, it's inactive.
Okay.
So like I said, this is a comet that doesn't turn on until it gets reasonably close
Okay.
to the sun.
Okay. And that's it right there. That's when you
So
predict the.
yeah, so this is just based on previous observations. So you have a
Okay.
asteroidal brightening, and then we have cometary activity.
Okay.
And the closest approach to the Earth, I mean, it comes within about 0.17 AU of the Earth. So it actually comes pretty close to the Earth. But it's an intrinsically faint object, and it's still 1 AU out, so it's not as active as it'll be when it's at perihelion.
Okay.
And then it drops back down, and then this is when you expect it to have just kind of returned to
Turn
its
off.
active asteroidal form there.
Okay.
And then here's a picture I actually took back in September 2005
Oh my.
of this comet. A very auspicious observing run because that was the same observing run I observed an asteroid called 1999 RQ-36 and decided this would make a good OSIRIS-REx target. And that asteroid was renamed Bennu and became the OSIRIS-REx
Huh.
target asteroid. So that's what I was doing on this observing run.
Oh my
When I
goodness.
wasn't observing Bennu, I was observing 169P neat.
Yeah.
And so that's really it for the expected bright comets of 2026. Now, of course, if history shows anything, there will be a whole bunch of other comets that haven't been discovered yet.
Right.
Either comets that have been discovered that become brighter than we expected, some comets we expect to be bright that will fall apart, and then there will be some comets that haven't been discovered yet that may actually be much better than the comets we're predicting here. And what I have is just kind of like the year at a glance, showing the expected brightness for northern hemisphere, southern hemisphere visibility for the six comets I showed. There were a bunch of comets I didn't talk about because I kind of made the cutoff at about magnitude 10.0. But there is a returning Halley family comet, 161P Hartley-IRAS, which will get up to around magnitude 10 and a half in late September, October. It comes around every 21 years. We talked about 10P Temple. Well, there was another Temple comet, 11P Temple Swift Linear, that will reach magnitude 13 or brighter in November. I say brighter because the comet has sometimes have outbursts. This was a comet that Temple and Swift discovered, and then it was lost for about a century before the Linear program picked it up not too long ago. The long period comet, C2024 T5 Atlas, which only gets within about 3 AU of the Sun, will reach around magnitude 11 by the end of the year. And a comet that really will be part of the comets of 2027, but will get close to the cutoff limit of magnitude 10 here at the very end of 2026, is our frequent flyer 2P Encke that comes around every 3 1/3 years.
Right.
This will be a really good return from the
Okay.
Northern Hemisphere, similar to the return in 1994. And even though it may only be magnitude 10.0 at the end of the year, it'll hit closer to magnitude 7 by the end of January.
Interesting. I don't see 168P on here.
Yeah, 168P is no longer with us, unfortunately, it appears.
No.
No.
Oh.
So for those that don't know, 168P Hergenrother was one of my discoveries that I found in 1998. When I discovered it, it was about 16, 17 magnitude.
Hmm.
I looked forward, going, okay, will it ever get close to the Earth in the future? And 2012 was it was going to be at its closest, about zero point 0.4 AU. And I'm like, well, you know what? Maybe if it goes into outburst during that return, it'll be bright enough I can see it from my backyard. And lo and behold, 2012 comes around and it goes into outburst, gets up to ninth magnitude. For like a few weeks there, it was a very slow time for comets, September 2012. And so it was the brightest comet in the sky
Hmm.
and was able to observe from the backyard. As a result of that outburst, it released a bunch of pieces that came off it, a bunch of different components, short-lived components, kind of like what K1's doing.
Okay.
We were able to watch those. And then it, drifted away and slowly faded and everything looked normal. And then the next time it was due at perihelion, never showed up.
Ah,
So
you've been ghosted by your own comet.
we've been ghosted by my own comet. I mean, that doesn't mean it's still not there. Maybe it became inactive and it's
Yeah.
going to turn on again. I mean, we've had comets that do that, but it's also possible it has just turned to dust,
Hmm.
literally.
Wow.
And so I mentioned earlier about the comet of 1744.
Hmm.
So this comet, which was actually discovered in 1743, is considered by a lot of people at the time was possibly the greatest comet of the 1700s. And it's got this famous woodcut here where this were, from the northern hemisphere, just showing these tails. And probably these are striations. It's kind of like what we saw with Comet McNaught back 2006,
Hmm.
2007. There had always been a suggestion that this comet might be related to a comet that was observed in 1402. And then Mike Meyer and Gary Cronk was my
Hmm.
predecessor, the Comets Section coordinator.
Hmm.
were able to confirm that yes, this 1744 comet was the same comet as the comet of 1402, as well as a comet in 1032 and another comet in 676, suggesting that this comet comes around every 300 or so years.
Hmm.
Possible that it's also related to the comet of 336 AD. Problem is, as you go further back, the data becomes sparser and sparser. I'll
Right,
use a
right,
different
right.
word, but it becomes harder and harder to make sure that, that the comets that were seen back then, where they were in the sky, what their path was. It's also possible that this comet is related to the great comet, well, we back in 43 BC, comet that we affiliate with Julius Caesar,
Hmm.
um, comet that was seen during the funeral games for Julius Caesar about a year after his death. That was so important to Julius Caesar's ultimate successor, the Emperor Augustus, that he actually put it on a coin.
Hmm.
What's interesting, when the comet came around in 1744 in one of the German states, it was also placed on a coin. So I don't know of any other comet that's shown up on multiple coins over history.
Hmm.
A lot of comets that made show, I mean, well, that have shown up on coins from multiple apparitions
Right, right.
in history. And so, yeah, so if this really is correct, and there's still some, the authors still have a little bit of doubt, but, we'll have to wait. But if it's true, then in 2097, late 2097,
Hmm.
we may have a great comet to look forward to.
I look forward to
Yeah, exactly. So make your
that.
plans now.
Yeah, I'll put it on my calendar.
Yep.
That's why. Now, over the years, the types of observations you're receiving have changed, and how much has like the smart telescope had an effect on what you're receiving now?
Quite a bit, actually. We're getting a lot of observations that are from smart telescopes. I have a lot of long-time visual comet observers, and when I say long time, getting up there in age, so
Hmm.
they're not doing as much visual observing,
Hmm.
have switched over to smart telescopes,
Hmm.
and they're reporting images, and in some cases, even reporting photometry.
Yeah.
While photometry isn't easy with one-shot color cameras, you can always isolate just the green band, and that's close
Hmm.
enough to V for the most part. You're within a few, tenths of a magnitude that it is usable. So we are getting a lot of data on that side. And I mean, let's be honest, it's all going to be smart telescopes in 5, 10 years if
Yeah,
the way things are going, because why wouldn't it be?
that's right.
Makes life so much easier. I mean, there's no reason to even have, why do I have to line my mount? You can just figure out where it's pointed and how to track
It
and
does it itself now.
does it itself. Yeah.
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 Wow.
And I'm looking forward to the days when, we can have larger smart telescopes to do that sort of thing.
Okay. Well, this is great, Carl. Once again, is there anything else you'd like to add for our listeners and viewers?
Oh, just if you want to learn more about the ALPO in general, you can go to alpo-astronomy.org. You can also go to the ALPO Comets section, which is that same address /comets. You can contact us at the ALPO Comets section at comets@alpo-astronomy.org. And if you want to get updates, as well as we produce a monthly publication, which gives our prediction for the upcoming month, you can get those off the Alpo Comet, the which is called the Alpo Comet News. You can get that off the publications part of the Alpo Comet section website, or you can go to the Cloudy Nights forum where we post these kind of an abridged version of
Hmm.
the Alpo Comet News, as well as allowing people to talk and comment on things. And you can find that by just going to the Comet Observing and Imaging section of the Cloudy Nights forums, and you'll see it's almost always pinned on the front page,
Hmm.
as well as at the top of the Comet Observing section, the most recent Alpo Comet news for that month.
Great, Carl. I want to thank you once again for coming on the podcast. It's a good annual event. Hopefully, we can get together during the year when some brighter comets pop into our view.
I'm sure there'll be something. There's always something to talk about.
All right. Well, thanks for coming on the podcast today.
Thanks, Tim.
All right. Well, that's going to wrap it up for this episode of the Observer's Notebook podcast. Again, I want to thank Carl Hergenrother for coming on the podcast today and sharing his insights to the comets of 2026. If you enjoyed this episode, please take a moment to give it a thumbs up and subscribe and share this podcast. It really helps us reach more listeners. New episodes of the Observer's Notebook are released every few weeks, and you can find us on iTunes, Spotify, and the ALPO YouTube channel. You can help support the podcast. You can donate through Patreon for as little as $1 a month. Up to $35 a month will receive exclusive benefits, including one-year membership to the ALPO and producer credits on the show. You'll find the links for our Patreon page on the ALPO website and show notes. A special thank you, as always, to our producers, Steve Siedentop and Michael Moyer, for their generous support. You can reach me directly anytime with an email at tim.robertson@alpoastronomy.org. Thanks for watching. You can join the Association of Lunar and Planetary Observers today. It's just this easy. You can become a valuable member of this International Lunar and Planetary Astronomy Organization, founded in 1947 by Walter H. Haas. It's based upon the structure of the British Astronomical Association. You can join various lunar and planetary observing sections, contribute to our massive archive of observations. You'll have access to our extensive lunar and planetary gallery of over 20,000 photos and observations of the sun, the moon, comets, meteors, and the planets. You'll receive our quarterly publication, the Journal of the Association of Lunar and Planetary Observers. You have the ability to join the ALPO training program, which will teach you the finer points of making planetary observations. You can attend our annual virtual conference, and you'll have access to the Observer's Notebook podcast. Membership begins at only $22 a year. The way to find us, just go to your Google and type in ALPO Astronomy, and you'll see this prompt come up. There's our association with our website, alpo-astronomy.org, and you'll come to our homepage. If you look at the top of the homepage, it says Join ALPO. Click on that, and you'll come to the sign-up screen. It gives you the information on the organization, and there's two ways to join. You can join by mail, where you will download a membership form, or you can pay online using PayPal. This is the PayPal processing page. You just fill out a few information lines, and then you're given the chance to click PayPal and join the association. Welcome to the ALPO.